Okay, welcome back everyone. So in this video we're going to take what we built in the last video and build on top of that. We're going to start using some standard libraries in Rust to manipulate files and open files and read them and do all sorts of things with the view of opening and reading FITS data, remembering that FITS is a common image data format or a data format. It's extensible, used in astronomy. And so we're going to start actually parsing that, or at least opening those files today. And so remembering back to the last video, we had a binary application that Cargo built for us, and it was just a hello world application that we updated. We've put a much more meaningful welcome message there. We're going to just probably make sure that that still compiles and works. So we'll just do cargo run, happy, everything works. So what we're going to do is improve this application and start using some of these standard libraries. But before we do that, we want to find some FITS data, and we want to actually download that, make that available, because we want to work with real FITS data as a test. The more FITS data we get, the better. In fact, it'd be great to have lots and lots of FITS data. So let's go across to NASA's website. So this is fits.gsfc.nasa.gov, and there is some sample FITS files here, and there's two in particular that I'd like to look at. They're quite different. This one is a 16 by 1600 array mosaic constructed from 4 different chips on the telescope. These are both from the Hubble Space Telescope, so that's what HST underscore means as a prefix. So that's really cool, right? So we're taking images or data rather that was captured off the mirror that's on the Hubble Space Telescope that was basically imaged using these CCD cameras. And then formed into FITS data to make available for research. So we're going to use these two files, and what I'm going to do is I'll download these to my local project or my local directory that I'm doing my work in. I'll make that available in the GitHub repo as well. And so to do that, I'll open up my FITS Rust folder here, and I'll just create a data directory. And then I'll take this one that looks interesting, and I'll just save that to, if it ever works, save that to the data directory, and I'll do the same thing with this other one. Save it here. So yeah, so they're two quite different files. If we go back up into Visual Studio Code, we can open these up and have a look at them. So this is the first one. This is, I don't know, it looks like we have some text data at the top and then a whole bunch of binary data that's trying to be, Visual Studio Code is trying to render that as Unicode text data or something. And then the next one looks similar, but it's got a lot more, well, it looks like at least it has a lot more sort of text data here. And then we have more binary image data down, or I guess it's image, could be anything, right? But we have more binary data, and then we have another text block down here. It's called a table extension. And then right at the bottom we have some numeric data. Looks like scientific notation for something that we don't really understand. So anyway, you can start seeing some structure here, can't you? Sort of text, binary, text, similar to this one, but just text and binary by the looks of it. So we're not really going to explore the detail of what makes up a FITS file yet. But we are going to start using these two FITS files to just, I guess, start interrogating, opening, playing with these files anyway. All right, so to do that, we're going to look at some, we're going to have a look at some common libraries that are used in Rust to do this kind of work. And the first that is particularly interesting, so if we just go in here and sort of update our program, we're going to use something from the standard library, std, called file system, or FS, and we're going to import a struct effectively called file. And so this file struct will allow us to open and read and write as well, and it does a bunch of other interesting things, and we've got some examples of how to use that. So that's the first library that we're going to use, or the first struct from standard file system, and then we're going to use standard, we're going to use path, and this will import the path struct. So let's go and have a look at the detail here. So this is actually a slice of a path. So it's not a string, it's a slice. We'll go into that later. And it can be used to represent paths to files on a file system. So we'll absolutely need to use that. We're going to also start using error handling. So we'll use the standard error. We'll import that as well. If I can type correctly, I need missing a colon there. So error is a trait, and I believe. All right. So what we're going to start noticing is we're going to come across something called the result type. That is a generic or a sort of a template type, and it returns either the type that we're after or an error. And error is a trait that probably implements a whole bunch of methods that we're interested in. Anyway, so we're going to use those three things, and we'll cover this more. Rust has a very specific way of managing errors and handling errors, and it almost always relies on using this parameterized enum type, like we've seen here, called result. Anyway, and we'll go through that in a little bit more detail. All right, so at the moment we're starting to see some warnings. So Visual Studio Code is pretty cool because you can install Rust plugins, and it basically will effectively try and compile the code as you write it, or at least check it for errors and syntax errors and what have you. And so it's just calling out that we haven't used these. So these aren't catastrophic errors because we're only just writing this code. All right, so the first thing we want to do is we want to get a path to one of our data files. So we're going to use this module, and it's going to give us a way of getting a handle to a path in the file system. Right, so to do that, we're going to declare a new variable, and the way you do that in Rust is using the let keyword. So we're going to say let, and we'll call it data path equal path new, and then a string literal to the path of the file that we're interested in. Now I really don't want to type that out by hand, so I'm just going to cheat here and take the file name. So it should be relative to our directory, so we'll just do the root of our project directory, or whatever you want to call it. So data slash, and then we'll put file name in .fits. Okay, so this will, let's just see what the return type is. The return type is a slice, path slice. Okay, good. So we'll do that, and then what we're going to do is we're going to use that path or data path variable to open a file, or rather, we'll get a handle on a file. And so to do that, we're going to use this file struct that we imported here. So we'll do let what are we going to call it? Let's just call it file equal file new. File open. And then the path, which is data path, and that should hopefully work. So we still have a few warnings about unused symbols and variables and what have you, so that's okay. So if we run this, we should see, not much, but we should see it run and compile and without error. That's good. Now what we're doing here, so if we look at what open does, open takes a path as an argument, and it returns something called an IO result of type file. Okay, so this is a parameterized type, and I'm betting that result is an enumeration. And so let's just double check that. So let's go and see. I think I've got that already open. Was that the correct type? Yep, IO result. Cool. So this is a standard IO result type. This is the definition, and you can see that it equals a result, and it returns the type that we're interested in or an error. Now let's just have a look at what the error is, or what the error does. Right. Okay. Okay. Cool. So we can actually call a whole bunch of functions on error as well. Anyway, we're not gonna look at that. So this is basically an enum. It's a result type, and it has those two components in it. It has the type and the error. And so what we're going to do in Rust, we have this keyword called match, and this match keyword is going to allow us to destructure things like structs and enums, and there's a whole bunch of other things we can do with it, it's a really powerful idea. And so what we're going to do is we're going to, instead of just opening file, or just calling file open, which returns this enum, that's what file will be. We want this to actually be a handle to the real file. So we're going to do match file open, which is an expression. And there's going to be two options. It's potentially going to return an error, or it's going to work. Okay. Now, in the case where it does an error, what we want to do is, if we can't open the file, then we're going to stop the execution of the program. And the way to do that in Rust is to use the panic macro. So we'll do panic, and we'll say something like couldn't open, and we'll say file name, and we'll put a reason. So these curly braces are basically placeholders for variables that will be interpolated into that string when that's printed. In this case, it'll be printed as standard error, I suspect. So we'll say couldn't open, and then we'll pass in, let's go data path display, so that we get something that is printable, and then we'll just say whatever the error was. So we'll just call it error.description. Okay. If we're able to succeed, if we're successful in opening the file, then we'll just return the file. Or we'll just assign this variable to the value file, which is the open file handle, or the open file. Okay, so that should give us a handle on the actual file. So let's run that and see if that works. Yep. Okay, looks good. Let's try breaking the file name and just seeing what happens. So I've just removed the last character. Good. It's complaining. It's throwing an error. It's saying thread main panicked at couldn't open data, and then printing the path. Entity not found. I'm sure we could probably get a better error description than that, but that's okay. All right. So we'll undo that. Make sure that we have working code again. Okay. Good. So happy days. So that's all looking pretty straightforward. Now, what we'll do is we want to read the contents of this file. Okay, so far we have a path. We're opening it. Now we want to actually sort of slurp up the contents of the file. And there's a number of ways we could do that. We could read line by line. We could, there's a number of different methods that we can call on file, or functions that we can call on file rather. But what we're going to do is we're going to use something. Well, firstly, let's create a data structure to store the contents of the file in. And so what we're going to do is create a vector. And so I'll do let fits data equal vector new. Okay. So a vector in that's interesting. All right, it's okay. I think I know what it's complaining about. All right, so what this is going to say is a vector is sort of like a growable. It's sort of similar to a to a vector in other languages, but it's something that we can just push entries onto and iterate over, and it's sort of a really common workhorse data structure in Rust, at least as far as I understand it. And so what we'll do is we're going to read every byte in the file, and we're going to put every byte that we read from file here into the vector. And it's not efficient. We're going to do that. We're going to sort of read the entire file in one go and store it all in the vector. But that just lets us process the vector and pass that around and do things with that later. So we can, close the file, or we don't need the open file handle. So it is complaining at the moment, and the reason it's complaining is that it's saying that it can't infer the type, and that's because we haven't told. So vector is a parameterized struct or parameterized type, and so what it's complaining about is that we haven't actually told it what type we're going to be putting in the vector. Now we could actually be explicit about that, but what Rust is good at is inferring that. And so let's write some code to actually use the vector. And once we do that, Rust will be able to work out what type of data we're putting in the vector. And so to do this, what we're going to do is call file readtoend. Okay, and readtoend will take a vector of type unsigned 8-bit integers, right? So this is 8-bit ints, unsigned 8-bit ints, which is all we need for storing the bytes in this file. It also needs to be mutable, a mutable reference, but we'll cover that. So let's just get started. Let's pass in a reference to fits data and just see what blows up. Okay, the first problem we have is that, does it throw the error here? It doesn't look like it. No. All right, let's actually run cargo run. Okay, what's it gonna say? Rust has really nice errors. I love it. I love the errors that the compiler gives us. So it's saying no method named readtoend found for type file in the current scope. Okay. Items from traits can only be used if the trait is in scope. The following trait is implemented but not in scope. Perhaps you add a use for it, which is just wonderful, right? So anyway, so standard IO is a module that contains a whole bunch of IO traits that we will want to use. And in this case, the read trait will allow us to use readtoend. Okay, so we could actually do something like this. We could say use standard IO and then a glob, and that would immediately make this function available. But we could also be a lot more explicit about it and just import and just use the read trait, which, I mean, it's really up to you. I don't know how efficient one over the other would be, but regardless, they're sort of our two options. Okay, and so now that we've moved past that error, we now have an error which is saying that that our reference to the fits data variable, and that's what the ampersand is doing. It's saying basically give me a reference. Is of a different, it differs in mutability. Okay, so this is where we get into a little bit about how Rust thinks about ownership and mutability and borrowing, and I'm not going to go through it in detail on this video, so I'm just going to sort of hope that you just trust me and follow along, and then we'll cover it as we go and learn more about Rust. And I'll refer you to some excellent documentation in the Rust book that goes over this in a lot of detail, or enough detail. So suffice to say that, firstly, whenever we declare a variable in Rust, its default is that it's immutable. It can't be modified. And so for the functional programmers in the audience, you'll probably smile and that'll make you happy. In pure functional languages like Haskell, everything is immutable, and that causes problems, or it causes challenges, or you have to think about your problem in a different way because of that. Rust, by default, makes everything immutable. But there are still really good reasons when you're writing Rust code to make data structures and variables mutable. And in this case, we certainly want that, right? So we've got a vector, and it knows what type it's going to store now because of our readtoend, basically implying that it's going to store unsigned 8-bit ints. But it needs to be able to be updated. It needs to be mutable. And so to do that in Rust, we add the mute keyword. Okay, so this makes fits data mutable. So that means that we can now add and remove things from our vector. That's great. Still doesn't fix this problem though, because this is saying borrow fits data. Okay, get a reference to fits data, but it's an immutable reference. Okay, and so what we need to do is explicitly make it immutable. Explicitly make it mutable. And so to do that, we just do ampersand mute fits data, and that will make that will mean that when we effectively reference or borrow, to use Rust terms, this variable for read to end, then it will be a mutable reference, or it'll be able to be modified. And so now that we're also now finding next error, cannot borrow file as mutable, as it is not declared as mutable. So again, we need to come back to our declaration of file and add this to say that file is mutable. Okay, so now we actually have no errors. We've got another warning though, which I think is just saying that the result of this is unused. So what does read to end give us? It gives us a result of type usize. Okay, and what it's going to do is read all the bytes into the end of until it hits end of file and put them in our vector. Great, but we are going to get this this result again, which is another enum. Okay, and look, we could go through the documentation again. Let's have a look. Read to end results. Okay, it's another enum. It gives us either a type, the type that we wanted, or an error. Okay, now, so guess what we do? We match again to destructure that, and then we have two options. We have error, we have okay. Okay, so let's just do the error part first. So we'll use panic again, and we'll just say couldn't read file. No, we'll just say file with, and we'll just do error again like this. Oops. And we'll do data path display and e.description. Okay, so that's the case where we get an error. In the case where we're able to read the entire file, we want to know what we're getting. And if we go back, we can see read to end, reads all bytes, placing them in buff. Yeah, but I'm just trying to see whether or not it tells us here in the documentation. Yeah, if successful, this function will return the total number of bytes read. And so that's actually what we'll get back here. We'll get the number of bytes. And so what we can do is we could say, use the print line macro to say successfully read however many bytes from whatever the file is. Okay, so we could just type pass bytes here, and we could do data path.display. Okay, so this thing should actually do something useful now. It should get a path, it should open, it does some error handling, create a vector to store bytes from the file, read right to the end of file, and then store that in the vector. And if it can't, it'll stop execution and print that out. And if it can, it will print a success message. So so let's just have a quick look and see what actually happens here. So if we run cargo run again, we can see welcome to Fits processing tool built in Rust, and then successfully read 69,120 bytes from data blah 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 blah. So let's just validate that, I guess. Let's have a look at what Windows Explorer thinks the size of the file is. So it thinks that the size of the file is 69,120 bytes. Success. All right, so so that's where we're going to stop. Actually, we're going to stop there because the video is getting long enough. I think we didn't get to the Fits part. We downloaded some Fits data and we started opening it and we briefly looked at it. But in the next video, what we'll do is go through and start writing a very simple parser. In fact, I wouldn't even call it a parser. We'll just start opening the data and data files and being pragmatic and starting starting to understand the data. To do that, though, we're going to finally go through and look at the fit standard, which is quite long and quite quite detailed. But we're going to we'll skip all the history stuff and we'll go down into the fits file organization. And then you can see here it goes through what a header and the data looks like and how extensions work and a whole bunch of other things that should be quite interesting. But we'll probably just start with the overall file structure, and we'll see that, there's a primary header and data unit, there's extensions, and then other special records. And we'll just start actually understanding that. And in fact, we already saw a structure like this, didn't we? We saw some textual header data, we saw some binary, that's probably what the primary data array is. And then I think we saw an extension, a table extension in one of them. Okay, so we'll do that in the next video, but at least what we've got now is a somewhat useful program. We're doing error handling. We're able to open and read an entire data file and count the number of bytes, and happy days. So that's great. So if this is interesting, please subscribe. Also, leave your comments below and just, remember, be constructive. I am a complete Rust newbie. I'm learning as I go. Yes, I've programmed in other languages, but not in Rust to any sort of significant degree. So I am still learning. If you're a Rust expert, then of course, please leave your comments about how I can improve this and what I'm doing wrong. I'm sure I'm doing lots of things wrong. But this is you watching me learn, and hopefully you're learning along with me. And I hope to see you in the next video. Thanks.